What happens when your OS starts? Have you ever wondered what actually happens when you turn on your computer? The moment you press that power button, a fascinating process begins. This process is known as booting, and it prepares your computer to run the operating system. Let's break it down step by step. First, when you power on your computer, the processor kicks into action. It starts executing instructions from firmware stored in a special memory chip. This firmware is often known as Basic Input-Output System or Unified Extensible Firmware Interface. The firmware performs a power-on self-test. This test checks essential hardware components like memory and disk drives to ensure everything is functioning properly. Once the power-on self-test is complete, the firmware looks for a bootable device. This is done according to a specific boot order that you can configure. The firmware searches for a program that can load the operating system. In systems using Basic Input-Output System, this is usually found in the master boot record on a storage device. For those using Unified Extensible Firmware Interface, it looks for an FI application in a dedicated partition. Next, the bootloader comes into play. This small program is responsible for loading the operating system kernel into memory. Different operating systems have different bootloaders. For example, Windows uses the Windows Boot Manager, while Linux often uses Grand Unified Bootloader or Linux Loader. If you have multiple operating systems installed, the bootloader may even present a menu for you to choose which one to start. After the bootloader does its job, the operating system kernel begins executing. The kernel is the core part of the operating system and manages hardware resources, memory, and processes. It is essential for the overall operation of the system. Following this, the kernel loads device drivers. These are software components that allow the operating system to communicate with hardware like keyboards, displays, and network cards. The operating system also starts essential services and utilities at this stage. These may include networking and security software. Finally, the operating system launches the user interface. This could be a graphical desktop environment or a command line shell. At this point, you see a login prompt, and the system is ready for you to interact with it. Different operating systems have unique boot processes. Windows supports both legacy Basic Input-Output System and Unified Extensible Firmware Interface, while Linux systems often use Grand Unified Bootloader for flexible options. macOS relies on Unified Extensible Firmware Interface and has its own bootloader for a streamlined experience. Understanding the boot process is helpful for troubleshooting startup issues or configuring systems that run multiple operating systems. System administrators and advanced users may even modify bootloaders to control which operating system starts. In essence, the startup sequence transforms a powered-off machine into a fully operational system. It initializes hardware, loads the kernel, and prepares the environment for user interaction. Each operating system follows this general pattern but uses different methods tailored to its design.